All right, welcome to class, everybody. If you haven't grabbed your final, you can come and pick them up here. I sent this out in an email, but just in case any of you haven't read your email, the class average was a little bit lower than normal on this test. And I think part of it is due to the fact that we have had some lower attendance over the last month or so. So I am offering a retake for the exam, but in order to get the retake, like to have it count on your grade, you need to attend class for the rest of the semester. So we have 7 more classes, including today. So if you attend 6 out of the 7 classes, then you can use that retake opportunity. So the way that the retake will work is you can come and take the test at any time during my office hour over the next 2 weeks. So my office hours are Monday, Wednesday, Friday at 9 a.m. and 1 p.m. So you can come and take the test at any point, but I won't put the grade in until the end of the semester after I've confirmed that you did attend class 6 out of the 7 times. So I'm going to pass this paper around for attendance. Make sure you get your name on that so that you're counted for attendance for today. And I will also send out a video that goes through all of the correct ways to solve the questions on this version of the test so that you can use that to study for the retake. So I'm hoping I'll get that done today and send it out this afternoon, but it might be tomorrow. That was really loud. But any questions on the retake or on the test? Okay. So our lesson for today is section 8.6. This is our last section in chapter 8. And basically it's learning how to graph learning how to graph quadratic functions, even if it's not automatically in the form that we learned last class. So last class, we dealt with equations that were in vertex form. And we looked at the stuff inside of the parentheses. And in this case, since there's a +1, that means that the graph is shifted to the left 1. Because remember, it's the number that would make this term equal 0. So a -1 is what would make this equal 0. So you can see that the vertex is shifted over to -1, and it's also shifted down 12. And that's because of this -12. So this is what we learned last class. Does anyone have any questions on that before we get started? Okay. So there's 2 other forms that quadratic equations can come in. One of them is standard form, and this is usually the form that it will show up in. We also have factored form. So vertex form is the most useful because it tells you where the vertex is, and that's one of the most important parts of a quadratic function. But standard form is also pretty useful because it will give you the y-intercept of your graph, because the y-intercept happens when x equals 0. And if x equals 0, when it's in standard form, it's pretty easy to calculate out what the y needs to be, because you would have 3 times 0 plus 6 times 0 minus 9, which tells you that y has to equal -9. And you can see on our graph here, that is the y-intercept. So standard form is useful for finding the y-intercept, but you can also find the y-intercept in vertex form, because again, it's just where x equals 0. If x equals 0, you'd have 0 plus 1 is 1, 1 squared is 1, times 3 is 3, and 3 minus 12 gives you -9. So you still get the same y-intercept regardless of which form you do it in, but standard form is kind of convenient for finding the y-intercept. Factored form is good for finding the x-intercepts, because if you have an x-intercept, that's going to be where y equals 0. So you would say, well, if y equals 0, what makes the equation true? Well, that's going to be x equals 1 and x equals -3. And you can see on the graph that those 2 points are x-intercepts. So factored form is nice for finding the x-intercepts. On your homework, you can, they'll give you stuff in factor or in standard form, and then you will need to find the x-intercepts. You can do it by factoring, or if you use the quadratic equation on this, that will also give you the x-intercepts. So you can decide on your homework whether it's easiest to use the quadratic equation, or if you want to convert the equation into standard or into factored form. So What we're going to be spending the majority of class on today is learning how to get it from standard form into vertex form. Because vertex form is one of the most important forms to be able to graph the equation, because it tells you where the vertex is. And the vertex is kind of like the key point for graphing a quadratic function. So let's go through a couple of examples to see how this works. So the way that we're going to get this equation into vertex form is basically completing the square, but instead of having the equation equal to 0, we have it equal to y. So when we complete the square, the first thing we do is we get rid of the constant on the side with the x's. And we also make sure that the x squared doesn't have a coefficient other than 1. So in this case, the x squared is fine because we have a 1 with it. But we do need to get rid of that plus 3. So I'm going to do that by subtracting 3 to the other side. And I get y minus 3 equals x squared minus 4x. And then remember, when we complete the square, we look at the number that's with the x and we find half of it. And that's the number that goes inside of the parentheses with the x. So we want the right-hand side of our equation to end up being x minus 2 squared. But this doesn't factor to this as it is right now. What do I need to add to both sides to make it so that it will factor to this? Yep, perfect. I'll add 4. Is everybody good with where that came from? Yeah. So just as a reminder, because it's been a couple days since we've done completing the square, ultimately our goal is to get to something times itself twice. If you were to FOIL this out, so I'll write it out and then I'll erase it. But if I were to do x minus 2 times itself twice, x times x gives me x squared. X times negative 2 gives me negative 2x. Negative 2 times x gives me negative 2x. And negative 2 times negative 2 gives me positive 4. And that is x squared minus 4x plus 4. And so this is what we need to have on the right-hand side in order to have it factor to this. Because factoring is essentially reverse FOILing. So what we did was we said, okay, I know it's going to be a negative 2 because that's half of this term. And then negative 2 times negative 2 gives us the positive 4. So that's the constant we need. So that's just a quick reminder of how we complete the square. Okay, so if I add 4 to this side of the equation to make it so it will factor to this, I can't just randomly add something to my equation without also adding it to the other side. So I'm going to add 4 over here. And this equals y minus 3 plus 4 will be y plus 1. And now this is almost in vertex form. The only thing I need to change to get it into vertex form is get y by itself. So I'll subtract the 1, and that gives me y minus 2 squared minus 1. And this is now in vertex form because the general form for a vertex form equation is that you have x plus or minus something inside the square. And then you can have something multiplied outside, and you can also have a constant out here. And so now that it's in vertex form, now I can figure out what my vertex is. So the fact that this is x minus 2 tells me that my graph is going to be shifted in the positive direction 2 units. So my vertex will be at positive 2, and then it will also be shifted down 1 because of this minus 1. So my vertex will be the point 2, negative 1. So on a graph, because a lot of your homework questions ask you to graph these, you would graph the vertex at 2, negative 1. And the fact that there's a positive 1 out here, or a positive number, tells me that it's going to be a parabola that's facing up. And so it will look something kind of like this. And I can figure out exactly how skinny or tight it will be, depending on, well, basically I could plug in any number except for a 2. So maybe I might find the y-intercept by saying if x equals 0, what does y have to be? So if x is 0, 0 minus 2 is negative 2. Negative 2 squared is positive 4. Positive 4 minus 1 is 3. So my y-intercept is going to be 3. And so that tells me my graph is going to look kind of like this. Any questions on that? Okay. So basically the process is just like completing the square. The only difference is when we completed the square before, instead of having a y, we had a 0. But the process is still the same. We're getting it into vertex form. So let's do another example. Let's do one. Let's do this one. Okay, so on this one, what would be our first step to get it into vertex form? Okay, perfect. So I'll add 15 to both sides, which gives me y plus 15 equals negative x squared plus 8x. What would my next step be? So when we complete the square, what number can we have with the x squared? Yep, it has to be a positive one, and right now we have a negative one. So let's multiply both sides by a negative to make that a positive. So we get negative y minus 15 equals x squared minus 8x. Is everybody good with that? Okay, so what are we going to want this to factor to? What perfect square will we be working towards? Did you say 4? Perfect, yep. So we'd have x minus 4 because that's half of this. But this won't factor to this unless we have a constant here. What is that constant? Yep, that will be 16 because if you multiply negative 4 times itself, that will give you the 16. So if I add 16 to this side of the equation, I also need to add 16 to the other side. And the left-hand side will simplify to negative y plus 1 equals x minus 4 squared. So now I just need to get my y by itself. So I'll subtract 1 from both sides, which gives me negative y equals x minus 4 squared minus 1. And then to get the y all the way by itself, I'll divide both sides by a negative, or you could multiply both sides by a negative. It's fine either way. And this thing right here is one single term. So when you multiply both sides by a negative, this whole thing is going to be multiplied by a negative. And you get negative x minus 4 squared minus 1. Yeah, it's very possible I could have made a mistake. So thanks for catching that. Oh wait, no, actually it would be plus 1. Yeah, because negative 1 divided by negative 1 will be plus 1. Thanks for catching that. Yep. So what does that mean my vertex will be? Be 4 positive 1 actually. Because this negative 4 tells me it's going to move to the right 4, but the positive 1 moves it up. So it's just the stuff inside of the parentheses. It might help if you think about it as the number that makes this 0. That's how much it moves, because if that's the positive 4, and then this is the number that moves it up and down. So this would be the vertex. Is this an upward facing graph or an upside down one? Yeah, it'd be upside down because the number that's being multiplied out front with the vertex form is negative. So that makes it an upside down graph.
So does that make it at the higher, higher end?
Yep. Yep. So like on your homework, it will say things like, what's the vertex? And then it will say this vertex is the highest or lowest point on the graph. And in this case, this vertex would be the highest one because it's an upside down parabola. And it would look kind of like this. And if you were asked to graph it, you would basically plug in some other number to find out just exactly how wide it is, but it would look something kind of like this. And I guess you could also get that into factored form and find your x-intercepts. That would be another way you could find those points. But probably it would just be easier to plug in some other number. All right, let's do a check-in. So scale of 1 to 5, how are you guys feeling about this process of completing the square and graphing them in vertex form? Okay, would it be helpful for me to do more examples? Give me a thumbs up if you want more examples, thumbs down if you feel like you're ready to work on your homework. Okay, I'm seeing kind of a mixture, so if you want to start working on your homework, go ahead and start. And those of you who want more examples, I'm gonna keep going through some more examples. Okay, so on this one, we don't have a constant in this case because there just isn't anything in the equation. So we don't need to add or subtract anything over. And the x squared is already with a coefficient of 1. So that means I can go straight to completing my square, which I will do by saying, okay, well, I want the term inside of my perfect square to be x minus 6. Because if I FOIL this out, that will give me negative, or sorry, I meant to say x minus 3. I want it to be x minus 3 because if I were to FOIL this perfect square out, I would get negative 3x twice, and that would add together to be negative 6x. But this won't factor to this unless I add a constant.
So if you FOILed it, then it'd be a positive 9.
X
Yep.
squared minus
And so that means we need to add 9 to both sides. Yeah, because if we were to FOIL that out, we would need the positive 9. So in order to factor this to x minus 3 squared, we need to add 9 to both sides. So I add 9 to both sides, and that gives me y plus 9 equals this stuff. So to get y by itself, then I just subtract the 9 over, and I get y equals x minus 3 squared minus 9. And so this tells me that my vertex is going to equal 3 on the x-axis and negative 9 on the y-axis. Because 3 is the number that makes this equal 0, and negative 9 is the number that's added onto the end. And if you weren't here last class on Friday, we went into lots of detail with this. So I'll post the recording. If you did miss class, you can watch that. So that would be my vertex. The fact that there's a positive 1 multiplied by the squared stuff means it will be upright. No, go ahead.
I was just gonna say, so you can plug in that number, right? And to see if it's true.
If you
Right.
plugged in a 3.
Yeah.
Yeah, so if you plug in a
3 is
3,
0.
3 minus 3 is 0, 0 squared minus 9. Yep. Yep. And that's specific, like the vertex will always make this stuff equal 0. But you could also, like, when you're graphing this, you know, you'll have like 3 and negative 9, which would be like way down here. So it'd look kind of like that. But then in order to graph it, like we know that it's an upward facing parabola, but we don't know exactly how wide it is. So you just choose some other number to plug in. Yeah, and if you wanted to get the y-intercept, you could just plug in a 0. So like in this case, you go like 0 minus 3 is negative 3, negative 3 squared is positive 9, positive 9 minus 9 is 0. So the y-intercept is actually also an x-intercept, and it goes through that point, and it looks kind of like this. But you could also, like, you don't have to plug in 0. You could also plug in like 4.
Some other number.
And-
Fine.
yeah. Because if you did 4, you get 4 minus 3 is 1, 1 squared is 1, 1 minus 9 is negative 8, and that would give you like this point right here.
So you'd be negative 4 down 8.
Mm-hmm. Well, it'd be positive 4 because I plugged in a pot. Mm-hmm. Yeah, and that would be like this point. So whatever point you plug in, it should still show up on the graph. It's just which one you choose to graph. All right, maybe I'll start going through some homework questions. Is there any particular homework question you guys have come across you'd like help with? Question 11 might be helpful for you guys because it's actually a really easy problem, but it's also, the form looks slightly different than what we've seen. So the equation on question 11 for me is x squared minus 7. So in this one, you actually don't have to complete the square at all because you already have the general form where you have something squared plus or minus something out here. Because the vertex form of an equation, whoops, wrong one. Vertex form is when you have something squared, and then you can also have it multiplied by something and something added out here. But you just have a, like, the x only shows up once in the equation and it's inside of something squared. And so on question 11, it's basically already in that form. And if you want to, you can think about it like this, if this makes it easier for you to think about it. Because essentially what it's saying is it doesn't move side to side at all, but it does move down 7. So this point right here would be my vertex. And then I could find any one of the other points to finish graphing my parabola. So I might choose to plug in like 1 or something like that. And I'd say if x equals 1, then y is going to have to be, yeah, -6. Yep. Because 1 squared is 1, minus 7 will give you -6. And so that gives you this point right here, which tells us that the parabola is going to look kind of like, well, that's bad, but kind of like that. So that's the form that will be. Oh, on question 5. So on question 5, you could go through and complete the square. So they gave me the equation y equals -x squared minus 10x minus 24. So you could go through and complete the square with this. However, this one's kind of unique because they gave you the x-intercepts. And one of the cool things about parabolas is that they're symmetrical. And so if you know your 2 x-intercepts, you know that the vertex has to be in between them, specifically exactly in between them. So the the x coordinate of my vertex is going to be -5. And so if you wanted to, you could just take -5 and see what y would have to be to make it true. And that would be your vertex. So that's an alternative way of solving the problem if you know your x-intercepts. I wouldn't necessarily recommend memorizing that strategy because it does require knowing these, and usually we don't know them. But on question 5, since we do know the x-intercepts, you could just find the vertex by finding what makes the equation true when x is -5, or whatever your numbers are. So if I were going to do that strategy, I would say, well, I know that x equals -5 is my vertex x coordinate. So to find out what y is, I would do y equals -5 squared minus 10 times -5 minus 24. -5 squared is +25, but then the opposite of that will be -25. -10 times -5 is +50. And then I have a -24. And so it looks like y is going to end up equaling 1, I think. And so x equals -5, y equals 1 is my vertex. And that tells me my parabola is going to look like this. So you can do it that way. But if you were to complete the square, you would get the same answer. You can do it either way. Do you guys have any other homework questions that might be helpful? Most of them are just doing that vertex form thing. Yeah, I do record them still, and I would say that because your attendance has been pretty all semester, so I'm okay with that. It will just be 2 days. Yeah. So just let me know once you. Sorry. Just let me know once you watch the recording and I'll know that as attendance because you have attended.
Thank you so much. Appreciate it.
Yeah. You plugged in X is 3. And that gives you 9, 15.
Because I haven't mixed it up.
Yeah. So if I give you 9 minus 24, negative, is it negative 15? Or total? Let me subtract Oh, it's not 8 times 3 at the end. It's just minus 8. Which makes that last term be a minus 8, now minus 24, which makes the number smaller.
Oh,
Thank you, we'll see you.
See ya. Yeah, that should fix it.
which number do, determine how we scheme?
You can do any number. So it's just whatever looks convenient. So like plugging in a 1, I would agree that's pretty convenient. So if x equals positive 1, then y would be negative 2. Because you get 1 squared is 1, minus 3 is 2.
Got it.
Mhm. Yeah, so if you
So
just
you
shift,
just have to plug that in for X,
yes,
whatever number I choose.
yes. The
Okay.
only thing, the only number you can't choose is the number you've already determined as your vertex. Because if
Okay.
you plug that number in, you'll just get your vertex again.
Okay, do like a 0.
Yeah, because if you were to plug 0 in, you'd get negative 3.
Okay.
Yeah.
So patient one.
Oh, you know what? This actually might be useful for a lot of people because I don't think I did one where the number.
Yeah.
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 Yeah. Let me do that for everybody. Okay, I'm gonna do question 9 on the board because I haven't done one yet where you have a number with the x squared. We did one where there was a negative, but if you have a number, you also need to work with that. So if you want to do number 9 with me, you're welcome to. So on number 9, I'll write out my original equation. So I have y equals 3x squared plus 2x minus 6. So to complete the square, I'm going to need to get rid of this 3 because the x squared needs to have a coefficient of 1. And I'm also going to get rid of this constant. So I'll start by getting rid of the constant and I'll add 6 to both sides, which gives me y plus 6 equals 3x squared plus 2x. Then to get rid of the 3, I'll divide both sides by 3, which gives me y over 3 plus 2 equals x squared plus 2/3 x. Is everybody good with that so far? Okay, so now I need to find out what half of 2/3 is. Because when I'm completing the square, I want the thing inside of my parentheses with the x to be half of whatever this coefficient is. So to find half of a fraction, you just multiply the fraction by a half. And so that would be 2/6. So 2/6. But 2/6 can be reduced to 1/3. So this is going to be 1/3, which makes sense because like if you were to FOIL this out, you would have 1/3 x time plus another 1/3 x, which would give you 2/3 x. But then I also need to have my constant added on to the end, which is this squared. So if I square 1/3, 1/3 times 1/3 will be 1/9. So I'm going to add 1/9 to both sides of my equation. Yeah. I did half of 2/3. So 2/3 times a half is 2/6, but 2/6 can be reduced to 1/3. Yeah. Okay, so now that I've got it here, this stuff factors to this, and then I need to simplify this side of my equation. So I'm gonna think about 2 as being 18/9 because that's the same thing as 2, but it has common denominators with my 1/9. And that gives me y over 3 plus 19/9. Is everybody good with that? Okay, then the next thing I'm going to do is just get y by itself because now I have my x squared stuff. So I'll subtract the 19/9 over, which gives me y thirds equals x plus 1/3 squared minus 19/9. And then to get rid of the 3, I'll multiply both sides by 3, which gives me y equals 3 times my x plus 1/3 squared stuff. And you don't want to distribute this 3 inside of here because you would actually have to like FOIL out the squaring part before you distributed it, which would undo the whole point of why we got it into this form. So you just leave it like this and you say I have 3 times all of this stuff. Then I also have 3 times negative 19/9. Well, 3 over 9 is going to cancel out some of the factors and I'll end up with negative 19/3 when I multiply by 3. And so what this tells me is that my vertex is going to, oh, question 9 is finding x-intercepts. Oh, well, that was a lot of work to find out the vertex when they weren't asking for it. Because to find the x-intercepts, you should just factor it. If it's not factorable, then you can just use the quadratic equation for it. So this is the way you would find the vertex though, if they had asked for it, but you don't have to find it. No. But this is what the vertex would be if you were to graph it. But they didn't ask for that, they just asked for x. So you can either factor it if it's factorable. If it's not factorable, then you can use the quadratic equation.